the function s equals minus 1/2 t or x plus n divided by 2 produces the set of points composing this line with a decreasing slope. Here, the function or s equals the sum of a series of numbers counting order 2 combinations for a series of sets of elements. This summing of combinations and elements has been explained in the combinatorial array video above and the spreadsheet below. The negative of this function plus 1/2 t or x minus n divided by 2 produces a set of points composing this increasing slope. Now, the coordinates of the points of this decreasing slope is inputs into a function 2s plus t, where s equals the y coordinate and t equals the x coordinate, will always give equal outputs. For example, here s will equal 0 and t will equal 1. And using the function 2 times s, which is 2 times 0, plus x or t will give you 1. Now, if we go to another point along the line, here we have y or s equals 1/2 and x equals 0. So 2 times 1/2 plus 0 also equals 1, just as it does here at the x-intercept. Now we can look at this place where this curve is crossed by this decreasing slope, and we have here that the s or y will equal 1 and the x will equal -1. And so 2 times 1 is 2 plus -1 will also equal 1. And we can look at this point across the y and x axis, where we have y or s now equals -1/2 and x equals 2. So 2 times -1/2 is -1 plus 2 is 1. So these points, the coordinates of these points as inputs into the function 2s plus t are all equal, which is a characteristic of that slope. Now, these coordinates as inputs into 2s plus t will always equal x. Of course, at the x will always equal the value of the x-intercept. In this case, it was 1. If I look at the next slide and the x-intercept is 2, it will be the case that all of these points will then input into the function 2s plus t will equal 2. In this case, x will always at the x-intercept, at the intercept, will always equal t and always equal n. That is, x will equal n always at the x-intercept. And of course, s will equal 0. The coordinate values for the points composing the decreasing slope might represent a set of element systems at a given rate of combinations or interactions equal S. These will be exhibited for a given number or expression of elements equal T. These element systems can, as we'll see, represent pre-quark fermions and bosons. The line of the linear function for the sum of order 2 combinations that we have exampled, S equals minus 1/2 x or t plus n divided by 2, includes points tangent to and intersecting the negative and positive curves, respectively, of the quadratic functions, these quadratic functions, for the number of order 2 combinations possible for a given number of elements. That is 1 minus 1/2 x squared minus 1/2 plus x squared plus n divided by 2x minus, in this case, c, representing this quadratic. And we can see that there are lines here at the intercept which are tangent to the decreasing side of that function, and here crossing the decreasing side of that function. Now, this line also includes points tangent to the decreasing side of the antiderivatives of this decreasing line, decreasing function. That antiderivative given as minus 1/4 t or x squared plus n divided by 2 over x, then minus c. And so we can see that this curve, the negative and positive curve of the antiderivative, is tangent here to the decreasing side of the positive one, and also tangent to the decreasing side of the negative curve. The coordinate values of the 4 total tangent and intersecting points indicate the T and V composition of Rishon expression elements. The X coordinate, or T, indicates the T composition, and the Y or S coordinate will indicate the V composition. Coordinates of lines with even x-intercepts will indicate bosons, such as 0 and 2. And the coordinates on the line where the x-intercept is odd will indicate fermions, such as for 1 and for 3. You can continue exploring these properties related to the pre-quark fermions and bosons, exploring the Rishon web pages to further investigate the association of these coordinates with the composition of Rishon expression elements.